condense it. Put here CH3, then I know there are 3 of them, then they are attached to one carbon, then I add the H. Also that is the same. Then of course the nomenclature following the laws, I can come up with the name of this compound. So what was the purpose of doing that? Of course you want to prepare an alcohol from, an alkene from an alcohol, but you can be given a primary, a tertiary, and then a secondary, which means that I should know how to differentiate between a secondary, a tertiary, and then a primary alcohol. But the ease of dehydration increases in the order tertiary, secondary, and then primary. So it is more easy to dehydrate a tertiary alcohol compared to a secondary alcohol compared to a primary alcohol. And that is why the temperature required to dehydrate a tertiary alcohol is less than the temperature required to dehydrate a secondary alcohol, which is also less than. So these ones here, actually this is third and the tertiary and then secondary, they just require a mild temperature, whereas this one requires heating 180 degrees to 1 watt. This one can even be 150 to 170, even to 180. You see? So taking an example of ethanol as an alcohol, CH3, CH2, OH. So there are many conditions here I'm using. Now of course I'm dehydrating, but this dehydration involves the use of concentrated sulfuric acid. It is a concentrated sulfuric acid which is going to remove the water. So it is conc, I put a dot, the short form of concentrated sulfuric acid. Then this is 170 degrees to 180, but I choose one temperature, don't put again 2. But now for learning purposes, let me put 180 degrees C. This is degrees C. So I have to choose only one temperature. If I'm putting 170, put 170. For 180, put 180. So because it is dehydrating, it is going to form more water as a byproduct. Then the important product there is going to be an alkene, because I know this is a method of preparing. I'm dehydrating. But what reagents I use for dehydration? It is concentrated sulfuric acid. Next time they will only put heat. This is a primary alcohol, so it requires heat. You heat. This temperature here can be just, sometimes I can say heat. When I heat, automatically I'm going to form an alkene, H2, because these are 2 carbon atoms. Therefore the alkene formed is also going to be having 2 carbon atoms, and then plus water. And organic chemistry balancing has no problem. So this is ethene, and then this is water, and then this is ethanol. Now carry out a mechanism of reaction. Now carrying out a mechanism of reaction, I'm going to have it in this way. I'm going to first of all dissociate the sulfuric acid, but it does not only dissociate on its own. So because it does not dissociate on its own, I first of all bring my ethanol here. This is CH3, CH2, OH. Then mechanism means that I'm showing how how bonds are breaking and how bonds are forming. So I'm going to bring here my sulfuric acid, but when I distort the sulfuric acid, it becomes this. I emphasize again, mechanism means bond breaking and bond forming. So sulfuric acid has 4 oxygen atoms. These are 3 plus 1, 4. Has 2 hydrogen atoms. This is 1, 2. Has only 1 sulfur, which is this one. So this is the same as sulfuric acid. Now because this sulfuric acid is surrounded by area of high electron, you see this oxygen here has lone pairs of electrons. Oxygen has 2 lone pairs of electrons, so it is using 1 lone pair. So which means that this oxygen is more electron rich. So if it is electron rich, you see electrons will now flow from it like this towards this hydrogen. Then this hydrogen oxygen bond breaks. Reason being, oxygen is more electronegative, then hydrogen is less electronegative, and therefore oxygen becomes partial negative, this hydrogen becomes partial positive. But this hydrogen oxygen bond breaks, and therefore this one shows me that this hydrogen is combining with this one to form two hydrogens, and then this bond between hydrogen and oxygen has broken. So when it has broken, which means that oxygen has taken back all the bonding electrons, and any species which is having electrons is negatively charged. For example, if I have chlorine atom and I add an electron, I'm going to form chlorine negative. This species is electron rich. In other words, it is a nucleophile. An electron rich species, it is represented by a negative. So here I'm going to form here CH1, CH3, CH1, CH2, oxygen. Because we have used lone pairs of electrons, it has donated it. This oxygen now becomes deficient. Deficient